We have all been here. You tap a button during a critical moment, the screen locks up, and the application simply stops responding. When an application crashes under pressure, the first instinct is almost always to blame the software stack. We assume the servers were too weak, or the database just could not handle the load. But systems rarely collapse because a developer chose the wrong brand of database. They collapse because the architect misunderstood how humans were actually going to interact with the software. Before writing a single line of code, you have to look at the expected traffic and ask one specific question. Are your users primarily consuming information, or are they creating it? In system design, we separate these two very different behaviors into read traffic and write traffic. If you try to build or scale an application without first figuring out which of those two forces dominates your system, a catastrophic crash is inevitable. Imagine a massive crowd staring up at a single glowing billboard. This is a read-heavy environment. Millions of users are logging in to look at the exact same information at the exact same time, like checking a public dashboard or browsing an online product catalog. When everyone wants the same data simultaneously, the only goal of your architecture is extreme speed. You have to deliver that identical information instantly, over and over again. To do this, we use a strategy called caching. Caching is the process of making temporary copies of your official data and storing them closer to the user so they load faster. These copies act like a shield. When thousands of requests pour in, they hit the temporary caches instead of the main database. The trade-off here is accuracy. If the original core data updates rapidly, those scattered temporary copies might lag behind for a few seconds, meaning users will briefly see outdated information. For read-heavy systems, that is a perfectly acceptable bargain. We intentionally delay real-time precision to guarantee massive availability and lightning-fast load times. Now, picture the exact opposite, a chaotic downpour of unique packages falling onto a tiny sorting desk. This is a write-heavy environment. Think of live chat applications, Internet of Things sensor networks, or continuous activity logs, where users are constantly generating brand new data. Caching is useless here. You cannot make temporary copies of data that has not been created yet. Every single incoming message or sensor reading is entirely unique, and every single one must be permanently recorded. If your database tries to instantly catch, process, and save 1 million unique records the exact millisecond they arrive, the hardware will lock up and the entire system will fail. The architectural defense mechanism for this is queuing. A queue is a digital holding area that catches chaotic incoming traffic and forces it into a structured single-file line. Instead of slamming the database all at once, the queue absorbs the massive traffic spike. It feeds the information into long-term storage at a slow, manageable pace. In a write-heavy architecture, you willingly sacrifice immediate processing speed. You delay the exact moment the data is saved to guarantee that zero ever dropped. Here is where system design gets difficult. Almost no real-world application is purely read-heavy or purely write-heavy. Modern software is always a collision of both. Take a standard project management app. On the exact same screen, you have drastically different human behaviors happening at once. The large main dashboard is displaying static project summaries, while a side panel is constantly scrolling with live activity updates and chat requires our read-heavy caching strategy. Thousands of employees are logging in at 9 a.m. to check their daily status, and that screen needs to load instantly without hitting the main database. But that scrolling chat feed requires our write-heavy queuing strategy. It has to capture every single rapid-fire micro-update from dozens of team members without dropping a single comment. If you tangle these two pipelines together, you are building a time bomb. A sudden massive burst of afternoon chat messages will overwhelm the database, which means the database will be too busy to load the morning dashboard. To prevent this, architects draw strict system boundaries inside the application. This physically isolates the fast read services from the heavy write services, ensuring that a traffic jam in one never destroys the other. True scalability is never about finding one perfect database that does everything. It is about observing how humans actually behave and drawing the right structural boundaries to handle them.